Here we want to find the parametric equations for the path of a particle that moves along the circle x squared plus y minus 1 squared equals 4. Well, when we look at this circle, before we do anything, let's make note that the center of the circle is located at 0 and then 1, and it has a radius of 2. So now let's draw a circle. So we have a radius, a center at 0, 1. We have a radius of 2. So now let's go ahead and draw that circle. So there is our circle with center 0, 1 and a radius of 2. So for part A, we want to describe the manner once around clockwise starting at 2, 1. So if this is where 2, 1 is located, we're going to go clockwise around the circle. Now before we do, let's write out what that equation is. We have x squared plus y minus 1 squared, and that's equal to 4. Okay, now we want to refer back to example number 4. And if you recall that in example number 4, we can multiply expressions by the radius r to get x, which is equal to r times the cosine of t, and y is equal to the r times the sine of t. Okay, so we're going to start with the cosine here. So here, this x squared is the same thing as taking the radius, which is 2, and multiplying it by the cosine of t, and then squaring it. Plus, if we look at the value of y, so far right now for y, we know that it's going to be 2, which is the radius, times the sine of t squared, and that's going to equal 4. So now from here, what we can do is we can let x equal 2 times the cosine of t. And now the reason why we're starting with x being cosine of t as opposed to sine is because when t is equal to 0, then the value of x is going to be 2, because that's what we want over here on our parametric circle here. So that's why we're starting with cosine of t. And so now we know that y is going to equal 2 times the sine of t. Now, in order for us to get 2 times the sine of t in our problem, it says minus 1. To cancel out that minus 1, that means we're going to have to add 1 to the sine of t. So these are the parametric equations of this circle. And now, since we want to go once around clockwise, then we have this restriction of t. And that t, to go once around the circle, will have to be in between 0 and 2 pi. Okay, so right now, when we look at these parametric curves starting at 2, 1, currently, when we look at these, if you're starting at 2, 1, it's going in a counterclockwise direction. So we're going to have to change something because we want to start at 2, 1, and it's telling us that we want to go in a clockwise direction, meaning that now we're going to go down as opposed to going in the other direction. And so in order for us to make it go clockwise, then we can keep the x remaining the same, but we need to negate the sine, so it's going to be 2 times the sine negative 2 times the sine of t plus 1. Because that means that whatever the value is for x, it's going to give you an output that's going to be negative. So that's how it's going to be able to start to go this direction. And keep in mind here, for the plus 1, we're not going to negate the plus 1 because we need to keep the center of the circle at 0, 1. So we're not going to change that. So the only thing that we negate is the negative 2 sine of t. And so therefore, this tells us that we're going to start at 2, 1, and then we're going to go in this direction in a clockwise once around the circle. Okay, now the next question wants us to go 3 times around counterclockwise starting at 2, 1. So we're starting at 2, 1. And now we want to go counterclockwise 3 times. So now what we want to do is, if we're going 3 times around counterclockwise, which means we're going in the other direction, then we are going into a different direction. So that means that the x is still going to remain at 2 times the cosine of t. And now y, if it's going in the other direction, we're going to leave it now as positive 2 times the sine of t plus 1. And now, since we are going 3 times around counterclockwise, starting at 2, 1, well then we also know that t is going to have to be in between 0, and it's going to go 3 times, so that means 2 pi times 3 is going to give us 6 pi. So therefore, if we start here, we go 1, 2, and then 3. So let's take a look at part C here. We want to be able to go halfway around counterclockwise, starting at 0, 3. So if we're starting at 0, 3, that means we're starting here at this point at 0, 3. Okay, so then that means that our trig functions are going to have to change for x and y. So what that means is that x is going to be 2 times the sine of t. Because that means that if we plug in 0, then the sine of 0 is going to be 0, and then we want to get 3 for the y value. So that's why we're changing cosine to be sine now. And therefore, y, if it's going counterclockwise, is going to remain positive. So it's going to be 2 times the cosine of t plus 1. Now, since we're only going halfway around counterclockwise, that means we're going here, and that's just halfway counterclockwise. Then that means that t is going to be in between 0 and pi, because pi would then represent half the circle as opposed to going the whole way for 2 pi.